Today is Thursday, August the 15th, and we are filming this video for electronic and engineering designs per connection diagram E2359, where we have a 2100 board, a dual SCR module. We don't have CT, and we have a lamp load. So here's our setup. There's the firing board. There's our dual SCR, and here we have our lamp load. On this particular setup, we're using 240 volts AC instead of 480 to power the SCRs and to power the board. We're going to be using a potentiometer, and that's a 0 to 5. So when we first turn the board on with 240, what we should see is, by the way, here's the 240 that we're looking from the line, and this meter will give us the output from the load. So we have a meter here and another meter here. We're going to be using a meter to measure different points, and what we have here is we're going to be looking on the scope the output across the load, and we have test point 7. Test point 7, it's the zero cross reference, which is this particular case 60 hertz 50% duty cycle waveform, and we're going to be looking on this initially TP8, although this channel will be moving around. So when we first turn on the board, we should have both LEDs on, and the first thing we're going to do is we're going to check that we have 30 volts DC. So with your common reference to the board common on that little hook, you can check anywhere on the 30 volts. Tony checks on the positive terminal of BR1, and you got 37, and that's unregulated. That's fine. He could have gone also to J3, position 3, to get the same point. It's just easier for him to get it there. But anywhere where you can pick up the 30 volts DC, it's okay. Now what has to be regulated is the 12 volts and the 5 volts. So the 12 volts, there's a couple of places. The simplest one is J1 position 6, and that's a 12.13 volts. Tony, can you go to position 3 really quick just to take a look at the 30 volts? So again, can be measured anywhere, but it's simple. So it's the same reading. And then the 5 volts at J1 position 7. All right, so those are values, and they are, as long as you are plus minus 0.2, you're okay. Now, the next thing, one of the things that we're not going to be able to show here, but we need to recommend you do is, Tony, can you take your meter and go across, well, you don't have resistor R3. In the board for this customer, for this application, the customer needs to go to R3 and measure the DC voltage across R3, especially when the SIG high is at the maximum, whether it's 5 volts or 10 volts, according to the configuration. So now, what we're going to do is go ahead and change that meter to SIG high, Tony. Okay. And we're going to leave it there. Alright, so this is at SIG high, and SIG high at 0. That's why the red LED is on. So as Tony starts increasing, when we get to about half a volt, that's when the red LED will turn off, and at that moment we'll start getting output. Before that, can you go drop a little until that turns on, and then show that we don't have an output? Right there, the meter went back to 0 on the output. So let's go ahead and start increasing. Stop at 1 volt, Tony, please. Roughly there. All right, as we increase SIG high, we can see that test point 8 changed. The duty cycle now it's starting to go ahead, Tony, keep on increasing. The duty cycle of test point 8, it's reduced, and we can see that across the load we're starting to see an AC waveform, and it's going to get there to the point that this duty cycle on TP8 is minimum. Now the AC input of 243 and the output of 242 are close to each other, and we can see our light bulb. So this is how you can check that everything's working fine. Right now, SIG high is at the maximum of 5 volts. Tony, can you reduce again, little by little, and then can we concentrate here on the scope? Alright, so that's TP8. Once you're down to 0, Tony, can you change, instead of TP8, now go to TP1. TP1 is the output of the buffer amplifier. Actually, you changed the wrong one. Bring that back to TP7. Alright, take the other one and let's go to TP1. Alright, at this point 1, we notice that we're at 0, and here we're at 0. So let's go ahead and start increasing that voltage. And one thing we notice is that as a TP1 increases, as a SIG high increases, TP1 it's also increasing. Alright, and it seems that we have here about 5 volts. Is that correct, Tony? On TP1?
No, the TP1 should be about 3.
It's alright. What we just need to show is that alright, you have about 3.
Yeah, about
right.
3.
So you have 3 volts when you have SIG high maximum 5. So go ahead and start coming down, Tony, and we'll see that changes accordingly. Instead of going to 0 to 5, it goes to 0 to 3. Now let's go now to test point 9, Tony. Again, the other one stays on TP7. It's just TP9 is the output of the LSI. It's the output. It's a firing signal to one of the 2 SCRs. All right, and again, you're at SIG high 0. Your red LED it's on. Let's go ahead and start generating output. Now that's the signal, and that's about 12 volts. Go ahead. That it's basically the same as TP8, the duty cycle. So as Tony increases it, the duration of that pulse train, it's there. And we also get the sinusoidal output. You want to come back, Tony? And the last thing that I want to do is I want to show now test point 10. And basically what we're doing here is we look at our 3 voltages, 30, 12 volts. You're going to be checking the voltage across R3. And now we're looking at SIG high. In this particular case, 0 to 5, we're looking at what TP1, TP8, TP9, and TP10 have to be. Alright, so let's go ahead and here we have the pulse module. So let's go ahead and do that. Alright, so Tony is slowly increasing SIG high. And this is what the waveform should look. And this is, of course, being chopping the 30 volts, having a resistor and a capacitor. So let's go ahead and come down, Tony, which again, it's also the same waveform and the same duty cycle as TP8. So this should, this test point will help you verify if everything is working okay. And again, it's important to verify that J2 positions 8 and 7 are in phase. And that's one of the first things that we check here. This is the end of this video.